Today I'll be discussing our forthcoming paper on developing a framework to guide the use of nutrient indices and environmental life cycle assessments. Nutrient indices, or nutrient profiling algorithms, are needed to rank and compare food items, diets, or production systems based on their nutrient density. Currently, however, there is a lack of transparency and standardization in using these metrics. Accordingly, we developed the points of differentiation framework to support the use of these metrics in environmental analyses. In particular, we place an emphasis on the use of these metrics as the functional unit, which is the unit against which environmental impacts are measured. And lastly, we not only examine nutrient adequacy metrics, but also nutrient diversity metrics. We identified 8 key points of differentiation to consider when using nutrient metrics in environmental analyses, including capping, which refers to if nutrient metrics should be truncated at recommended intakes, weighting, reflecting that not all nutrients hold the same relevance within a diet, reference amount, across the board versus group specific, dietary and/or context specificities, disqualifying nutrients, selection of nutrients for the metric, and validation of the metric. Some key highlights we found: the choice of nutrient metric used as the functional unit can greatly affect environmental sustainability rankings. And in terms of nutrient rankings themselves, the points of differentiation that had the largest influence include energy standardization and nutrient selection. And in general, we recommend that there be stricter guidance on nutrient selection for these metrics. Additionally, dietary and context-specific metrics can offer valuable insights as opposed to using more generalized metrics. We also found that more research is needed regarding metrics for heavily fortified foods that might be high in disqualifying nutrients, which includes things like sugar or saturated fat. Additionally, there's a greater understanding of how to handle these disqualifying nutrients. For example, the utilization of ratios is useful as the impacts of disqualifying nutrients can be mitigated by those of qualifying nutrients. So an example of this would be the potassium to salt ratio. And lastly, more work on food functionality is needed, referring to issues of bioavailability, which is important because not all nutrients that we consume are absorbed and utilized by the body. And we also need a greater understanding of food processing effects.